Good afternoon, ladies and gentlemen. My name is Hsieh from Swancor Group. And first of all, I would like to thank KCA and IA and Chairman Park for inviting us here to present our recyclable thermosetting materials. And the brand name is called the EzCiclo and the Cleaver. And this is the content of my presentation. And first of all, I would like to, using a few slides to introduce Swancor. And Swancor is a holding company in Taiwan. And we are also a listed company in Taiwan and China. And here we have three major business units. The Swancor Advanced Material is producing the epoxy resins and also the vinyl's resins. And in 2015, we started our Sunwell carbon fiber composite. Currently, we are major supplying the protrusion profiles for the wind turbine blades. And also, we do some prepregs, carbon fiber prepregs. And the third part, we have an innovation and incubation center. And it's devoted to the new materials and technology development, and also the M&A area. And also, we did some research on the carbon capture usage and storage area. And this is the 30 years. Until now, we have 650 employees, and also our sales revenue is around $320 million US. And currently, we have 5 factories located in Taiwan, China, and also Malaysia for the resins. And for the carbon fiber composite, we have factories in Taiwan and China. And we schedule to have our European site in the next year, Q4. So our vision is to devote it in the product and service in the green energy, environmental protection and safety. So as I mentioned earlier, our epoxy vinyl ester, we start from 1992. Currently, I think we are the first supplier in Asia area. And also for the wind turbine epoxy, we start from 2007. And currently, we can supply the total solution, including the resins and adhesive, to the tier 1 turbine supplier, and also the carbon fiber protrusions for the turbines, for the large turbine. And in 2022, we launched our recyclable thermosetting materials. So we view ourselves not only a material supplier, and in the near future, we hope that we can become a circular economy solution provider. So that is why we developed our EzCiclo. And this is the material sourcing. And also, when we do the recycle, we need to use the Cleaver. And the second part, let's go into the product introduction. And all of you, I think, are the professionals from the composite. And we all know that the biggest issue for the thermoset composite is that it's very hard to recycle. And currently, it can only be landfilled or by incineration. But I think in the near future, the landfill way will be soon be prohibited. And also, the incineration will cause some pollutions. And before we go into the product concept, let me show you a brief video to let you more easily understanding.
Composite materials are widely used in our lives. However, the toughness bonding between the fibers and thermosetting resins make up the composites have made it very difficult to recycle for a long time. The current method of recycling composite materials is not only costly, but also produces a variety of harmful pollution, or becoming to the Earth's landfill waste for years, lying in the ground. Swancor established the ESG Committee in 2015 to integrate company resources to promote sustainable development. In 2022, Swancor launched recyclable thermosetting resin EzCiclo and degradation agent Cleaver to solve the necessary evil in this industry for 90 years. EzCiclo resin series can be adapted for infusion, pultrusion, pre-preg, filament winding, and hand layup processes. In this video, you can see Swancor's customer using EzCiclo pre-preg resin to make car spoilers. After years from the installation, the car spoiler has reached the end of life. Trim down decommissioned car spoiler and cut into suitable sizes. Pour the trimmed car spoiler into the degradation equipment, add Cleaver degradation agent. Through heating and stirring, the fiber and resin can be separated. The separated carbon fibers are then dried in an oven. Recovered fibers can be utilized in injection master batch of PP, ABS, PA thermoplastic resins, as well as the fiber mats and SMC, BMC, which greatly reduces the consumption of raw materials in the process and makes it possible for material reuse and circular economy, and provides great added value to FRP industries. A true sustainable future. EzCiclo makes it a better world. Devoted to carbon neutrality and new materials innovation.
After this video, I'll use this diagram to simply explain again about our design concept. And the EzCiclo itself is you can call it a modified epoxy. So we did some modification to the basic epoxy structure, combined with the different hardeners so that you can use it in a different process for the composite. And we can use, if customer using the EzCiclo to manufacture the composite and into different kind of application like sporting goods, wind energy, and also the automotive parts. And eventually when the product goes to the end of life, then we can use our Cleaver technology to separate the resin and the fiber. And the difference between our technology and with the traditional solvolysis way is that we can reuse the reclaimed resin and the Cleaver, and to make it a almost zero waste recycle process. So the product made of EzCiclo can be degraded by Cleaver, and we can reclaim the recycled fibers. It can be glass fiber or carbon fiber, and also the recycled oligomer. And for the recycled fibers, we can use it for the molding compound like SMC or BMC, or we can use it to produce a fiber injection master batch. And also, we can use it to produce the carbon fiber mat or carbon fiber papers, so that you can combine with our EzCiclo to produce another recyclable composite. So for the EzCiclo series, as I just mentioned earlier, we already developed products for different applications like infusion, pultrusion, pre-pregs, and filament winding. and it can be used in the transportation, wind energy, or architecture, and also the sporting goods. And also for the pressure vessels, we also have a product for the hydrogen tanks. And I'm not trying to go into the detail of our product specification. If you are interested, you can go to our booth. And I'll just illustrate some practical examples. And this is the thermostat, the first recyclable thermostat CFRP bicycle that we got the Innovation Award this year in JAC. And so for this example, we produced the frames, handlebars, rim set, totally made of the EzCiclo prepregs. And also, we can use prepregs to make automotive parts, and also the sporting rackets or stick. And also, we can produce protrusion plates for the wind turbines. And also for, just like this morning, Professor Hart just mentioned, we are cooperating with Professor Hart to produce recyclable pressure vessels in the future. And for the wind blades, currently we are already cooperating with Siemens Gamesa to manufacturing blades over 90 meters. And in China, we also have customers, which is Zhuzhou Times. It's producing 86 meters. The long blades is already castered. And next, I would like to briefly introduce our recycle process. For our recycle process, this is the lab scale, and we take the carbon protrusion plate as an example. Firstly, we need to cut it into small pieces. The reason why we need to cut it is there are two reasons. First of all is that when we talk about the application of the future recycled carbon fiber, we need to define its length of the carbon fiber. So that's the first reason. And the second one is that because we are kind of like a solvolysis chemical way of recycle, we need to increase its surface area to enhance the recycle efficiency. So when we cut it, and then we put our cleaver, cleaver is our degradation agent, and we put it into the reaction tank, and normally we will heat it up to 150 degrees for 4 to 6 hours, and then we can reclaim, and the resin will be degraded by cleaver liquid, and also after the drying, the fibers can be reclaimed. And this is the answer to this morning. Someone have ever asked Professor Ha about how we recycle the pressure vessels. And as you can see, the first picture is that we take the pressure vessel after the burst test, and we cut it into like a 6 centimeter square, and then we'll put into our Cleaver reaction tanks. And after the reaction and the separation, we can get the dry fibers. And not only in the lab scale, currently we also have some facilities for large scale recycle. So in Taiwan, we have a facility which can handle 40 metric tons of recycled composite. And next year, we are planning to have another facility which can handle 150 tons per unit next year. So in China, we have the capacity to expand to 2,000 metric tons of fiber recycling, composite recycling. And next, let's talk about how we use the recycled materials. And first is the fiber. For the recycled fibers, currently we already get the world first GR certificate, which is a 100% recycled carbon fiber. And the reason why we got the GR certificate is that for the GRS, you need every step during the recycle need to be documented. When you're collecting the waste and you do the recycle and you sell the recycled materials, it needs to be documented. And that means that all these recycled fibers are traceable. And this is very important for some customers. And for the recycled fibers, just as I mentioned, we can produce into a mat or veil, and also the master batch for injection molding. And we also have some mat and veil sample in our booth. And we can reproduce it with a molding compound into bicycle parts, like a crank and crank arm, and also some bottle cage by injection molding or press molding, also some backpack case. And currently, we're also trying to cooperate with our customer because I just mentioned we are not only providing the recyclable materials, but also our customers always ask us, how can I use this recycled material back into my industry or into my products? So let's take this bicycle as an example. We did the frame and the rim and the handlebar and the front fork with fresh materials, fresh pre-preg, which is recyclable. But at the other side, we can also use those recycled material by molding or by injection molding to create some other parts which using the recycled materials. That will be even attractive to the customers. And I think many of you will be curious how we use the recycled oligomers. Currently, we have several formulations. In general, we can reformulate those degraded resins and into some applications. In general, or marine or chemical corrosion, anti-corrosion. And this is an example. This is our, we reformulate the recycled epoxy resin into hand layup resin. And if we compare with the general spec of the hand layup resin, and it performs quite well compared to the new one. And also, for some applications, we can use our oligomers to synthesize different resins. And for the general purpose or the marine or the anti-corrosion applications. And that is, we use these oligomers to synthesize polyester resins. Okay. So because we can fully utilize those reclaimed fibers and oligomers, so we can also get the certificate from the ISO 14021, which means that the products, the composite parts made of our EzCiclo, the recycle rate can be over 95%. And the last part is that we will do some simple comparison with the different ways of recycling. So many professionals has explained that before. And so in short, the pyrolysis will use a high energy. So the carbon footprint will also be high. And due to the high temperatures, it will deteriorate the fiber's properties. So may limit its usage in a future application. And for solvolysis, the biggest problem is that it will cause the waste. And because it's normally use solvent or strong acid to do the recycling. And our ways, using EzCiclo and Cleaver, I think we have the lowest processing cost. And because we can reuse the resin and the fibers, so I think we can create more values than the previous recycling routes. And we have some internal calculations talking about a carbon footprint comparison. And if we consider the synthesized and also the final recycled waste, and we calculate the carbon emission, then I think for our internal figures, it's only 1/10 of the existing thermosetting epoxy resin. So in summary, our technique, the EzCiclo and Cleaver, you can just treat it like a normal epoxy. So the benefit is that firstly, it's already commercialized. We can fully control the raw materials and the technique. And you don't need any new facility or process to produce the composite. You can just treat it like a conventional thermosetting composite process. And we can meet the ISO 14021 standards, which means that the composite using our technique, the recycle rate can be over 95%. And we also, for the recycled fibers, we got a GRT certificate, and which means that it's traceable. And we can reduce the carbon footprint by using those recycled materials. So this is my brief introduction of our materials. Thank you. Okay.
Thank you so much for wonderful presentation. Time-wise, it's perfect. Yeah.
First of all, I would like to thank you. You're coming. I invited you just less than 2 months ago, but you came here and the booth. So thank you for your collaborations. I have a question. This recyclable system, is it new chemistry, which means should be registered as in rich registration as a new chemicals, or modification technologies, which is not needs requirement of rich registration as a new chemicals?
I think it still belongs to, for the rich, currently we're still investigating, but I think because it's just a slightly modification for the basic epoxy, so I think it can belong to the same categories. Yeah.
So it's not new chemicals?
Yeah, yes.
Okay. Secondly, your recycle process, it looks like a soluble cyst, but it's a new process. Normally, there is a lot of approach in new technologies to making recycling.
Yeah.
Separate fiber and resin. And currently, the problem is they can do short fiber. They chopped and then they separate.
Yeah.
So how long you can make it long lengths with your process, the recycled carbon or fibers? How big size of that? Because short fiber, we can use, of course, SMC or some application, but short fiber, very limitation of application.
Yeah.
So how long lengths you can make it from your recycle process?
Okay. So based on, sorry for that. So based on the applications of our applications, currently, the longest fiber that we can use is, we can handle is like 8 to 10 centimeters long. Because for molding compound, it's maybe 1 or 2 inches. And for master batch, maybe shorter. But if we're going to produce like a mats, maybe it needs 6 centimeters to 8 centimeters. And for the veil carbon fibers, maybe only 1 centimeter. So currently, of course, if we can retain the longer fiber, maybe we can develop more application for that. But currently, we are also involving our recycling facilities. We have first generation, second generation. We are also trying to increase the fiber length that we can handle. Yeah, that's the current situation.
Okay, well, thank you. Yeah, Professor Park.
Thank you for your very nice presentation. You show me the comparison of three different recycling carbon fiber method. First, the pyrolysis, second, the solvalysis, and your own method.
Yeah.
Can you show me the last table?
Yeah.
Not this table.
I know.
Table just before the end of.
Yeah.
And my question, the pyrolysis. I asking you about the sizing problem. Pyrolysis, you deleted most of sizing material from the carbon fiber surface.
Yeah.
But solvalysis looks like some residual sizing is still exists 1%, 2%, sometimes 3%. And how about compared to pyrolysis and solvalysis? How about your methodology? How can you control the sizing material and before and after your
Yes,
method?
that is a very good question. And maybe in some applications, some like for if we want to combine with a master batch, maybe they don't want the residual sizing on it. Yeah, but if we are doing some like a mat or the veil, if we are combined with a thermosetting resin in the future, maybe some sizing left on it will be better. So currently we can control that by the treating times, because currently maybe after treatment, maybe less than 5% of our weight of the sizing will be left currently. Yeah. Yes. Yes. Yes.
By the way, if we have any question about the sizing, and talk to Professor Park, he's
Okay,
one of
of
the
course.
world experts.
Yeah. Okay.
Okay,
Thank you.
well, is there any questions? Well, if not, okay, thank you so much again.